Alright guys, I'm Dr. Cadell and this is the cycle of copper reactions. So in this experiment, what you do is you take some copper, we're going to weigh it out, and perform a series of chemical reactions on it. It'll transform each time and it'll look quite a bit different. And at the very end, we're going to get that copper back out. It's going to look a little different, but it's the exact same copper, the same exact atoms of copper that we started with end up at the end. And we're going to also weigh how much we start with, how much we end up with, and see how close we come to satisfying the law of conservation of mass. So the series of chemical reactions are right up here on the board. Reaction A, the first one we do, what this says is we're going to take the solid copper that we weighed out, and this is basically nitric acid broken apart. We add some nitric acid to it, and what happens is the solid copper is converted into the copper 2 ion, which is going to give the solution a nice blue color, and the nitrogen dioxide gas, that's dark red fumes, which is toxic, so we definitely don't want to breathe that in, which is why we have to do that step in the hood. After we do that step, we're going to take that copper 2 ion that's going to be in solution, we're going to add some water to it and all that, and we're going to do the same reaction that we did in the gravimetric analysis lab. We're going to add some sodium hydroxide to it, and what that's going to do is that's going to form the copper 2 hydroxide, bright blue color. Then we're going to take in reaction C, and take that copper 2 hydroxide, heat it up, and form solid copper 2 oxide, that dark brown substance, and some water. Then in the next reaction, we're going to take that copper 2 oxide that we formed, add some sulfuric acid. This is basically the sulfuric acid here. What that does is that dissolves the copper 2 oxide into copper 2 ion, and we get sulfate and water out in the end. So this solid brown substance, now it'll be a blue solution. Then we're going to take that copper 2 ion in solution, add some zinc metal. In this step, what we're doing here is we're reforming our solid copper that we started with. The way this happens is the copper 2 ion, which is an ion, so it's in solution, pulls off 2 electrons from the zinc metal. When it does, now it's not an ion anymore, so it doesn't dissolve in solution, it's a solid. And the zinc becomes an ion, it's up in solution. Now remember how the copper 2 ion gives the solution a blue color? The zinc ion does not give it any color, so it's just a clear solution at that point. Which is really nice, because the way we tell that this reaction is finished is we start out with a blue solution, and when all of that blue is gone, then we can be confident that all of the copper has been converted from the ion into the copper metal. And the last thing we're going to do is there's probably going to be some zinc metal left over because we add some excess zinc in this reaction. So we're going to take some hydrochloric acid and just dissolve that zinc metal. And we're going to get hydrogen gas off at the end. So we're going to have to do this in the hood too, because hydrogen gas is flammable. That's what we're doing, so why don't we go over and get started on that reaction. All right guys, so the first thing that we're going to do is weigh out about 0.9 grams of copper. That's the copper metal that we're starting with, looks just like copper, into our 250 ml beaker. So place the empty beaker on the balance, tear the balance, take it off, start adding some copper. Too much. We don't want to really add too much copper, because if we do, we won't have enough nitric acid in the next step to use it all up. So the amount actually does matter. And there we go. So write that number down in your data table, 3 places past the decimal. We're ready to go over to the fume hood, which we have to do this next step in, add some concentrated nitric acid to the copper. So let's go on over there. All right, guys, now that we have our copper weighed out, we can do the first reaction, reaction A, which is where we add about 5 mils of concentrated nitric acid. Remember, it's extremely important that you do this reaction in the hood and not take this out of the hood until you've added the DI water, which is next. So to measure out the 5 mils of the concentrated nitric acid, I'm just going to use this transfer pipette. It has marks. I'm going to take 3 mils and 2 mils. So what I do is pull it up, about 3 mils, and it starts reacting right away. That's the nitrogen dioxide that you can see. Nasty, nasty stuff. You want to make sure you do not breathe any of that in. What happens is if you breathe it, one of the things that happens if you breathe that in, the nitrogen dioxide reacts with the water in your lungs and makes nitric acid in your lungs. Not good. So as it's reacting, we want to make sure that we get all of the copper reacting. And if you can see that blue color, that's our copper 2 ion in solution. All right. I'll know it's finished when there's no more copper metal that I can see. It's all converted to the copper 2 ion, and there's no more nitrogen dioxide, the dark red fumes being given off. So that looks pretty good right there. So again, before I can take it out of the hood though, I need to add my 10 mils of deionized water, which I have right here. That in. Now it's safe to take out of the hood. Bright blue, copper 2 ion, we're ready for the next step. All right, guys, so now we're ready for the next step, which is exactly, by the way, the same reaction we did back in the gravimetric analysis lab. We're going to take the copper 2 ion that's in solution, and we're going to add some 6 molar, about 10 milliliters of 6 molar sodium hydroxide to it, just like this. And there we go. It's that bright blue flocculent precipitate. I guess it's flocculent. That's copper 2 hydroxide. Okay, that's that reaction. We just did that next reaction. The next reaction is to heat this up and convert this to copper 2 oxide, but there's not enough liquid in here. We need to add some more. So we're going to add about 50 mils of DI water. I don't really measure this carefully. I use the marks on here. Bring it up. There's already some in there, so I'll bring it up past 50. And one of the observations that would be useful is that when you feel this, it's warm. So, yeah, some DI water. Put it on. I'm going to take my magnetic stir bar because as in the gravimetric analysis lab, if we don't continuously stir this, it will bump and it shoots everywhere. So we're looking, guys, for the same thing that we did in gravimetric analysis. We're looking for this bright blue color to turn all dark brown. That's the copper 2 oxide from the copper 2 hydroxide. We also want to make sure that we rinse down the sides, get all that copper in solution. The goal, one of the things that you learn in this experiment is that transferring, see that bumping right there? Got to be careful about that. Is that whenever you transfer something from one container to the other, and we do that a lot in this experiment, you lose some of the material that you're transferring. Our goal in this experiment is to transfer every single atom of copper that we started with until we get to the very end. That's our goal. All we can do is the best that we can, and some of the tricks are to make sure that when you transfer something, you rinse it well so that everything gets transferred, or as much as you can gets transferred over. You can see down in the bottom where it's closer to the heat, it's already started to turn brown, but at the top where it's not quite as hot, it's still blue. So we're waiting for everything to turn dark brown. That way we'll know, oh, the copper 2 hydroxide has been converted to copper 2 oxide. I saw it bump in there a little bit, so I wanted to turn up the speed of the magnetic stir a little bit higher. With this one, if you're looking at the top, you might not see the blue, but if you look through the side, you can a lot of times see that the top layer, there's still some blue in there. Now, if we get impatient in this step and we take it off too early and there's still some blue in there, that means there's still some of those copper atoms that are in the form of the copper 2 ion that are in solution. And because they're in the solution, they'll get lost. So we really want to make sure we get it all converted without bumping. That looks pretty good right there. It's all brown. So what we do now, turn off the hot plate, take some beaker tongs, set it on the wire gauze. Now we're ready for the next step. All right, guys, so now that we've converted all the copper 2 hydroxide into copper 2 oxide, let it settle down, we're going to decant the liquid off the top. That just means we're going to pour the liquid off the top. And remember, our goal, every time we transfer something, is to not let any of that copper get transferred over. We want to keep it. The brown stuff is where the copper is in the form of copper 2 oxide. So I have this waste beaker right here, and if you can see it in the top, it's clear. The copper 2 oxide is the brown stuff in the bottom. So my goal is to pour most of the liquid off from the top without letting any of the copper 2 oxide get transferred over. Now that's almost impossible to do perfectly, because I don't know if you can see, but there's some floating around. We just do the best we can, and we don't worry about getting all the liquid transferred over. That's not important. So I'm going to stop there because I saw some pieces of copper 2 oxide starting to float up to the top there. So I'm just going to leave that water in there. Add about 25 mils of DI water. Doesn't have to be exact. Close enough. This is called washing. I'm going to wash the copper 2 oxide. Try to get everything that's not copper 2 oxide out of there in water. Because there are other ions floating around in there. There's some nitrate from the nitric acid, some sodium from the sodium hydroxide, I'm going to stop there because I saw some copper 2 oxide starting to get transferred over. I'm going to do that one more time. Add about 25 more mils of DI water. Good enough. Yeah, give it a little swirl. Let it settle down. So if you can see that there's still some cloudiness up here, I want to wait until it settles down a little bit and is more clear. So we're going to set this down and we're going to wait for a few minutes. All right, guys, so now that we gave the copper 2 oxide a chance to settle down, we're going to decant the last washing off the top. Again, we really don't care about getting all of that liquid out. Our goal is just to try not to let any of that, or as little of that copper 2 oxide get transferred over as we can. Yep, a little piece went over. I'm going to call that good enough. So now this, we can just throw down the drain. In the next step, we're going to add about 30 milliliters of 3 molar sulfuric acid. So what this will do is this will dissociate the copper 2 oxide and we'll get copper 2 ion in solution, so we expect it to look blue again. Let's see. Put it on the stir plate, give it a little stir. You see it start to turn color, it looks green now, and now it's starting to turn blue. See how it was cloudy before with the solid copper 2 oxide? Now it's a bright, clear, beautiful blue solution. Get off. That's all it takes. So now, guys, where we are at is we have the copper 2 ion up into solution, and we want to pull it back down as solid copper metal. To do that, we're going to add some zinc. Remember, zinc's going to donate an electron to the copper 2 ions, reforming the copper metal. So we just take about a scoop of this stuff right here, put it in. This one takes a little while, but you can see already that solid copper, that's copper metal on the bottom, is starting to form. So we can stir this a little bit. So we're going to let that set. It's going to take a little while. When we're finished, we'll know when we're finished, guys, when there's no more blue in the solution, because that means all the copper 2 ions have been converted back into copper metal. All right, guys, so now we know that the reaction has finished. All of the copper 2 ions have been converted into copper metal, that brown stuff at the bottom, because there is no blue in the solution. It's pretty good. We've got all the blue out. So now we're going to decant the liquid off the top. Try not to let any of the copper get transferred over. This is our waste beaker still. Now there's some zinc metal floating on the top. We don't care about that. We're going to get rid of that anyway, so I don't care if that gets poured over. It's the copper metal on the bottom that I'm trying to make sure does not get transferred over. And again, we don't care about getting all of the liquid, just as much as we can. That's good enough. Okay, so now there still is some zinc in there. We're gonna, in the end, we're gonna dry this stuff, and over the week, come back and weigh it the following week. So we want to make sure that we just have copper in there and nothing else, which means that the zinc that's probably still in there, we want to get rid of. So that's the next step we're going to do, is we're going to go back to the fume hood, add some concentrated hydrochloric acid. That will react with the zinc metal, producing hydrogen gas and dissolving it, and then we can wash that off of the copper. So let's go back over to the hood and do that. All right, guys, so now the next thing I'm going to do is I'm going to take this magnetic stir bar remover and take that magnetic stir bar out, set it aside. And to get rid of any zinc that might be left, we're going to add about 10 mils of 12 molar hydrochloric acid. Remember, we have to do this in the hood. Now, sometimes there is no zinc left. It's all been used up. If that's the case, you won't see anything happen, and that's okay. But if there is some zinc left over, what you'll see is fizzing, some bubbles. That's the hydrogen gas that's being produced. So let's see what happens here. Yes, there it goes. See that fizzing? That's the hydrogen gas that's being produced by the reaction of the zinc metal with the hydrochloric acid. So we'll know that our reaction is finished, that all the zinc has been removed. Not exactly removed. The ions are still in there, but they're ions in solution. They're not solid zinc metal anymore. When there's no more fizzing. Sometimes it takes a little while. Just kind of give it a stir every now and then and let it react. So we know that the reaction's finished now, guys, because no more bubbles. All the zinc's gone. What we do now is we decant the liquid into our waste beaker, same waste beaker. Again, being as careful as we can not to let any of that copper be transferred over. Doesn't matter if we don't get all the liquid. Now we're going to wash it with water 2 times, about 50 mils. I'm not going to even measure it out. I'm going to use the marks on here. The exact volume really doesn't matter. Swirl it around a little bit, let it settle, pour it out, decant. Do it again. And decant. Actually, what I do is I see there's some copper on the sides. I don't want to rinse that. I don't want to rinse that into the waste beaker. So I'm going to first rinse it down with a wash bottle, DI water. Doesn't matter. I'm going to pour this out anyway. The water. There we go. Okay, so now we have wet copper here. We have one more thing to do. That's, by the way, that copper right there, same exact atoms of copper as we started with, and that shiny copper metal that we weighed out in the beginning, exact same atoms. So now what we need to do is rinse it with some acetone. I'll tell you why in just a second, but first I need to dump this waste, which is just water, down the drain. Because the acetone waste we cannot dump down the drain. We have to put that into a special waste container, organic waste. So I'm going to take some acetone, nail polish remover basically, add about 20 mils. The exact volume's not really important, close enough. What this does, guys, is when we rinse it with the acetone, this pulls all the water out, and it's still going to look wet, but it's going to be wet with acetone. Now, when we let this dry over the week in our lockers, the acetone will evaporate easily, and when we come back in a week, that will be dry. Because we weighed the beaker in the beginning, all we have to do when we come back is put the beaker with the copper, the dry copper in it on the balance, get that mass. Because we know the mass of the empty beaker, subtract that, and that'll give us the mass of the copper. What we want to do is we want to find out how close that is to what we started with, law of conservation of mass. Now this waste, I'm going to pour into my waste beaker, and then later I'll put it into the organic waste container. Now if we don't quite get it all out, that's okay. This will absolutely evaporate over the week. And that's all there is to it. We'll come back next week, weigh the dry copper, and we're finished.